Good time of the year, everyone. This is Ivan from EPIC, the European Photonic Industry Consortium, and we continue the series of our online events dedicated to new product releases from the members of EPIC. Let me remind you that EPIC is the largest consortium of photonic companies in the world. We are now over than 800 members in Europe, but also globally. And we help our customers, our members with market research and also on the technology side. So today we have 5 very exciting products that come out on the market. And the first product will be presented by Anand Pandy, the application engineer leader at Excelitas. And this will be a series of photodiodes that enable optimal alpha particle detection for radon gas detection applications. We'll also hear from Ritika Singh Petersen, the business development manager at Stensborg, that will present the new and improved world's smallest roll-to-plate nano-imprint lithography machine. And first presentation given by Oliver Faehnle, co-owner at PanDao. And PanDao, that is a software with which you can push the button to check the fitness of your optics fabrication. Then Charles Dumas, the international sales director at Gentec, will present the Miro Altitude, Gentec's new top-of-the-line power meter for laser beam measurement. And last but not least, Hooman Banaei, the CEO at Everix, will present the ultra-thin dielectric filters manufactured like optical fibers. So not keeping you wait any longer, I will pass the word to Anand, please.
Yeah, thank you.
Yeah,
I can start sharing. Even if you could confirm if you could see my screen, and I'll proceed.
Not yet.
Not yet. Okay, give me a second. Okay.
Perfect.
Okay. Thank you. Thanks for confirming. I'll go into the presentation mode. First of all, good morning, good afternoon, and good evening, wherever you're joining from today. My name is Anand Pandy. I lead the applications team at Excelitas for the detection products. And I really thank EPIC for hosting the call today, and EPIC and the whole team there at EPIC. Today, I'll present the Excelitas new series of photodiodes, the VTH series of photodiodes for alpha particle detection, particularly focusing on radon gas detection applications. I'd like to take the opportunity to thank the team here at Excelitas, particularly the team here in Montreal and Manila, who are mainly involved in this product development. Okay, maybe before I go into the product itself, I'd like to take a couple of minutes or maybe less to talk about Excelitas and what we do. Excelitas is a complete end-to-end photonic solution provider, meaning we have products supporting a lot of illumination with lasers and also take care of transmission of the laser or light sources through various optics and optomechanics, and at the end, detection of light with multiple detection solutions. So our portion of the discussion will be focused on the detection portion and who we are. So Excelitas is a global company with headquarters in Waltham in the USA, and we have multiple R&D and manufacturing sites across the globe. So I'm from Montreal, and that's where these detectors are fabricated. And we also have a lot of work happening in our Manila site for this particular product. But other than that, there are multiple locations. So what is radon, and why do we need to monitor radon? So that's what I wanted to start with a quick introduction. So radon is a radioactive inert gas. This basically comes from the decay chain of uranium, which is colorless, odorless, and tasteless, which makes it difficult to detect. And being radioactive, it is dangerous gas for human beings. So EPA recognizes radon as a leading source of cancer among non-smokers, so which is pretty serious. And radon usually occurs in the nature, so it's coming from the ground. Since it's a gas, it could continue kind of expanding within the environment by water or whatever it is. But in open air, usually it is not a problem because the concentration dilutes. But in an enclosed space like a home, it can start accumulating within the house and it could raise a concern for health. So that's why it is important to monitor radon on a regular basis to make sure that you're not exposed to radon. And early detection is very important. So you can take countermeasures to kind of vent your air or whatever to make sure that your home is free or having a low concentration of radon. And the important thing I want to also mention is there's a lot of connected smart home devices that's in place now with smoke detectors that's already connected to your smartphone, giving you early warning, right? So I think it's a good time to have a radon detector that's connected, and then it can provide continuous warning, or if there's an increased level of radon in your home to the users at the end, so that people could take action depending on the radon level in their home. Okay, and radon detectors come in many forms, but a couple of things I want to highlight. This is a lot of text here on the slide, but just quickly wanted to say there are multiple different types of detectors. And typically, radon takes a long time to detect. And a lot of tests are like short-term. Even when I say short-term, it takes 1 or 2 days to get the short-term test. So that's pretty normal. But the only problem with that is you have to send these samples to external lab for getting your actual radon concentration. So which is not practical in some ways, because these days you want to see what is happening right then and there. So it doesn't make sense to make a measurement, send it out for a lab, and then do a measurement, and then they report back on what is the concentration. So that's basically, even though it's a short term, it could take many days before you can actually see. And long-term detectors are usually much longer. It takes about 3 months. The value is it gives you a good average over time and what is the concentration in that period of time. But it doesn't give you a constant or continuous measurement. So the main importance that I wanted to mention is when you have a continuous monitoring, then it gives you information right then and there, and then you know the trend over time and you can take appropriate action. So this is where the semiconductor detector comes into play. There are many types of continuous detectors, but semiconductor detector is much more practical. It's easier to use. I'll talk about that in the next slides. And that is basically with a pin photodiode. And that's what I'll be talking today. So in general, what are the key requirements for a good radon detection, good low radon concentration, because you want to really measure this at low radiation levels? Like I mentioned before, these usually need a long measurement time and a larger detector area. Whatever detection method is, you need a larger area so you can absorb the alpha particles and do the detection. And also how this setup is done, the collection setup or the channel volume, this all influences the measurement. And these are the key parameters, and silicon photodiode typically covers all of them in a nice way, particularly in the long measurement time. A pin photodiode can be used for a continuous measurement. So you are looking at the trend over time, and it gives you a better indication on how it changes over time. And silicon pin diodes are suitable for radiation detection, especially for alpha particles, because it can detect in the surface. So that's important for radon detection. And it has a good energy resolution and has a good absorption depth for greater absorption. And I mentioned many times before, continuous measurement, and it's ease of use. You can just bias the detector, and with a simple amplification circuit, you can really make a good, nice radon detector. And it's more compact and lower cost compared to other like continuous measurement methods. And with that, Excelitas is introducing a new series of photodetectors specifically suited for radon detection. So the product is called VTH21 series photodiodes. There are 2 different detector sizes that we are launching now, 5x5 and a 10x10. These are usually large enough for alpha particle detection for radon. So this can detect alpha particles directly. So these are bare die photodiodes. These are not enclosed in any housing. And that's what you need, because you want the alpha particles to hit directly on the surface of silicon. And that's being converted into signal, and then it's back and processed. So a large area, as I mentioned earlier, is good. It increases the high detection probability and wide operating voltage range. So you can bias them at a higher voltage to reduce the capacitance, and which means you can detect much faster, and also it has a lower dark current. And these are unsealed detectors, so you need to have the design in a way that it is highly reliable, even operating in an unsealed environment. So this has been designed with that in mind. And last slide, just to kind of wrap up with the key specifications on these two detectors. I mentioned these can operate up to 100 volts, so that's the breakdown voltage, and junction capacitance is usually very small, 30 picofarad for the 5mm detector and 120 for the even larger 10mm detector at 20 volts. And these detectors, they expect people to be biasing them at 20 to 40 volts range. And this still has a low dark current in that region and has a good depletion thickness for absorption. And also, it has a very thin dead layer on the top to minimize any dead layers thickness, and the absorption happens in the depletion, and it can result in good detection in lower concentration levels in an early time for this application. So with that, I'll open up for any questions anybody might have. And we are excited to launch this product and hope this will serve a lot of homes to detect radon and have an early detection to improve everybody's life at the end.
Yeah, thank you very much, Anand. This is very exciting to see this kind of product. And I was wondering how compact can it be together with the packaging and the battery and everything? Can it become a wearable device?
It cannot become a wearable device because you need a kind of a chamber, for example. So these are usually like your smoke detector that you would mount in a house, for example. And typically these are mounted in the basements of the house because that's where the main source is. So that's where you want to detect. So that's a typical assembly or mounting location for the device.
All right. I see we have another question from Lars from Technical University of Denmark. Please, Lars.
Thank you, Ivan, and thank you very much for the presentation, Anand. I'm a little curious because so happens that I worked with dosimetry. So how do you make sure that your silicon detector does not measure background radiation?
So it's basically the alpha particle detection, background radiation, meaning the optical light or other alpha particles. Can you elaborate?
But I'm still curious because I mean, unless you have some kind of absorber material, any cosmic ray will also get into your silicon detector and give a signal. I mean, this is why when you do silicon detectors for Raman spectrometers, you often see in the use panel that there is a thing called background subtraction, and the background is not background, it's background radiation, because you will see spikes in the spectrum.
The energy spectrum. So you're looking at the energy spectrum distribution, the energy levels, right? So the energy resolution, that's why that's critical. So you're discriminating based on the energy resolution for the particular alpha radiation they're looking at for radar.
So your instrument or system is used with an energy discriminator.
Exactly. Yeah. So the end design would have some kind of energy discriminator too.
Okay.
Yeah. So the energy resolution is important. So the photodiodes are good in the energy resolution space. Yeah.
Okay. Thank you.
Hope that helps. Yeah. No problem.
Is there any other question in the audience? Because if not, let's think Anand again, and I will pass the
Antonia has a question. Antonia.
Oh, okay. Go ahead.
I was curious about the point you mentioned about making the detector available for free space use. What's the challenge to have this free space use in your case from the manufacturing point of view?
Yeah, usually like when you have a free space open detector, right? Because it has to be a bare silicon detector, and the humidity and temperature might degrade the performance of the detector over time. So you need to have proper protection layers on the detector to have extended lifetime, and also in humidity, in high humidity. Those are key concerns on any general photodiode when you are operating in an open environment. So you need to make sure that you have some protection to make sure it can work in extended period of time in high humidity and temperature. So we have protection layers and coatings on the detector to be able to work in open air, if you want to call it. It's open air, but it still has some kind of a chamber, but the air is flowing through it right at the end. So we need to make sure that
environmental conditions, let's say.
Yeah, exactly.
Okay, thank you.
No problem. Thank you. Thank you for the question.
Okay, thank you, Anand, again. Let me pass the word to Ritika Singh Petersen, the business development manager at Stensborg, and she will present the new desktop R2P nano imprinter.
Yes, thank you. Just let me know if you can see my slides. Can you?
Yeah, that's good.
Okay, so I'm good to go. Yes, thank you. So yeah, my name is Ritika Singh Petersen, and I'm a business development manager in Stensborg. And today I'm going to present regarding new and improved world's smallest roll-to-plate UV nano imprint lithography machine, which we call desktop R2P nano imprinter. Just a quick slide on what we do in Stensborg. So Stensborg is basically involved in the roller-based UV nano imprint lithography solutions. So we have off-the-shelf desktop R2P nano imprinter that I'm presenting now. Plus we make, custom-made higher volume production machines that are roll-to-roll and roll-to-plate. Also, we provide consumables that go on these machines. So the imprinting resins and the imprinting templates. So coming back to desktop R2P nano imprinter, this is a desktop machine that is very easy to learn, operate, and maintain. And this has been by choice because we think that this machine is an ideal prototyping machine for process and product development. So every time, you have a new material or you have a new master design, or you just want to shift to a new process. So let's say you have been using the typical MEMS manufacturing technique so far in your research work, and now you want to try something that is nano imprint lithography or some other process, then this tool provides that ideal condition for prototyping without a lot of wastage of material and energy. And we all know we are in some kind of energy crisis right now, so that's good to save. Plus, at the same time, it is a very fast replication machine that can replicate features in micro and nano dimensions down to, a few 150 to 100 nanometer with sub-nanometer precision. And all the power of the machine comes from basically the two patterns we have in the company. So first one is regarding all the optics that is contained in this cylinder of the roller in the machine. And the other one is to use that optics, the method regarding that, and then actually do the printing process. So the printing process looks like this. We have the roller and then you have the stage. So that's moving. And then the roller comes into contact with the stage at a very line contact. So that's the beauty of roller-based process. So this is the place where the contact is happening as compared to, the conventional plate-to-plate manufacturing techniques where there's an aerial contact. In a roller-based process, it's just a line contact. And this is where the resin that is deposited on the substrate is not only patterned, but it's also cured, and almost at the same place, it is demolded. So it's a really fast replication process. And without, a lot of the issues of the plate-to-plate manufacturing techniques, like, for example, some of the typical ones are bubbles and defects and all those things. So what's new with this machine in 2022? Well, the machine has been enhanced and improved with different things. First of all, the magic potion, the optimized UV light source is even better optics now. Then there is a better compensation for different substrate thicknesses. We have improved design for several mechanical parts. And then the plate motion has been upgraded so that we can do really low speed operations. And what does this all mean? That the machine has become even more versatile in terms of, when you have a really low speed operations, you can cure even the really hard resins. So these are some of the highlights of the machine. And what can machine do? Well, here are some things that we have done with the machine. You can see that there is a really complicated 4-level DOE beam splitter that has been replicated quite, in a high accuracy with our machine. Then there is also this hydrophobic surface, which is a microstructure. So it's a big structure with the holes in different materials. And then we can also do really high aspect ratio patterning with this machine. So the machine is multifunctional. It can be used for nanoimprint lithography on a hard and flexible substrate. It could be used for fabrication of template, and it can also do processes like reverse nanoimprint lithography. And with this multifunctionality, the applications are really like quite a broad spectrum of that. So from photonics, optics to, even life sciences. So you can imagine that you can basically imprint on the substrate, and that substrate becomes the device, for example, for DOE, or you can actually imprint the surface of the substrate, and then it makes a functional substrate, and then you can use it as a mask edge or something like that. So that was it from my side, and thanks for listening. Yeah. So any questions?
Yeah, thank you, Ritika. It's a beautiful machine you have built there. Do we have any questions in the audience? I was wondering again, what are the dimensions of the system? Is it really tabletop?
So if you look at the length, width, and height, then it's just 670 millimeter in length, and then 380 millimeter in width, and 320 in height. So it's just 26 kg machine. Basically, you can lift it and put it on the table, and you don't need a clean room facility for that. So yeah, any table is enough. Yes.
Okay, that's impressive. Antonio, please go ahead.
Yeah, I was curious, in the case of the micro-optical components, what's the lateral resolution you can achieve if you make different tests? What's your limit up to now?
So lateral resolution mean XY direction, right? Or the
Yeah.
Z? Okay. Yeah,
XY.
so we don't know the limit so far. So we have been, doing some tests based on whatever we have been asked to do. The lowest we have gone for a client is 100 nanometer with the sub-nanometer accuracy. But we have also seen that some of the defects that they had on their masters down to 10 nanometer has been replicated like 1-to-1 copy. So exact replication of that. So we think that we can go down to even few nanometers. Yes.
Wow. So small micro lenses, arrays of micro lenses will be a perfect application
Yes.
for this kind of machine.
Yes, and even high density gratings and things like that is doable. Yeah.
Yeah. Wow. Yeah. Thank you.
Yeah, there's a wide range of applications I can imagine for this machine. Well, thank you very much, Ritika.
Yes,
And
thank you.
if there is no other question in the audience, I will pass the word to Oliver Faehnle, the co-owner of PanDao. And PanDao is push the button to check the fitness of your optics fabrication. Please,
Okay,
Oliver.
can you see my screen? Yes.
Just make it.
Hello?
Yeah, just make it full screen.
Yeah, sure. Okay,
And
so
to go.
I'm Oliver Faehnle from a company called PanDao, and my last name is quite complicated. Sorry for that. We are a software company and part of Epic, and Epic generated for us, when we became member, a whole new category, supply chain design software. So I will explain you what this is, and then I will explain you very shortly what our new product is, which we will release next week. So we all deal with optics. Optics needs to be designed, optical systems, to serve a certain application. And while you design optics, you need an optics designer, like this guy here. And he is very nicely helped by optical design software tools like Simex, Code5, Oslo, and so on, to design the optical system needed for the application. But the next step in the generation of the optical system is the fabrication. And this interface from design to fabrication is exactly where PanDao moves in, because today this is still based on human-to-human interactions. You need to talk to each other and ask, can you fabricate this design? How much will it cost? How big is the danger, or how low is the risk? And that's where we move in we developed, that's our standard product, a software tool that readings the optics design and simulates optimized fabrication chain, helps you to know the cost of your optics when it will be produced and the risk you have if you want to have it produced. So basically it makes the optics designer more happy. And how do we do this? Well, we read in due to ISO standard 1010 optical drawings, and we need, of course, to know how many lenses you want to produce. And then PanDao harvests among 360 different technologies available to produce optics, ranging from diamond turning to ion beam figuring to magnetorheological finishing and so on, all 360 possible techniques, and that makes them compete with each other to be allowed to be in the best fabrication chain for this piece of optic. So the output of PanDao software, that's our standard, is the most cost-efficient fabrication chain. And on top of that, we also give the fastest fabrication chain, because sometimes you have to deliver next week, and then you are happy that you can deliver, although it might be a little bit more expensive. Well, what can you do with that? Well, here is a lens that you read in. It's an A-sphere and made of glass. And it has just a short glimpse that you know what I'm talking about. It has a certain shape accuracy, and this results in a fabrication chain. This case, finishing with wheel polishing, and this lens costs, for 5,000 pieces you want to produce, $115. If you now change the shape accuracy during design, you can check what the impact is on fabrication. Like you go to a 5th lambda, starting from 2 lambda to 5th lambda, and then you see different technologies move in and what the price changes as well. Or you go to a 10th lambda, then again technologies change and the price changes again. So this is what you can do with PanDao, and this is the standard we harvest among these technologies, and we give you the best fabrication chain. So what is our new product, which we will release after this nice meeting here? This is another kind of software, PanDao, and this reads in NDA protected the fabrication technologies you have. If you are a fabrication company, optics fabrication company, then you don't have those 340 different technologies available. You have some of these. And of course, you are interested to have the best results possible on the market, but first of all, your CEO is interested whether you can do it with your own technologies available. So we read in your technologies, which are of course not the amount available out in the market, and then you get the best fabrication chain based on your own available fabrication technologies, and can compare that with the best fabrication chain if you would change and go to a supplier, or if you invest in something. So what is your gain? Your gain is you can determine the delta of your best fabrication chain for this optics to the best fabrication chain available in the market. So either you can prove, hey, we are better than the market, or you see we are more expensive, so let's invest in a new technology to stay competitive. The second thing is you can evaluate your own or your supplier's fabrication chain. You ask your supplier, okay, you want to produce our optics. So what do you have available? And then they tell you what kind of technologies they have. And then you check what will this be costing if they do your optics. And then you can compare that again with the market available. So this helps to save risk and money. And the last one is, of course, you can, if you have a fabrication booth, you're really good, and then you can prove to your own company or to your customers your excellence. You can show that our own fabrication chain is optimized for your product. So look, you don't need to check for other suppliers. You already found the best one. So that is our new product. We call that the company performance software addition to our standard PanDao software solution. And with this, I want to thank you. And these are the 3 owners of our company. In the middle, I am, that's Rolf, and this is Marco. And we are happy to demonstrate this. And again, next week, we will launch that. Thanks a lot.
Thank you, Oliver. This is a beautiful product you're developing. I was wondering, actually, how do you distribute it? Is it based on an annual fee, or do you buy it once and you have it for forever?
Cool question. Well, it's running completely in the internet. You have to have a login, and then you run it in the internet. You don't download any software. And yes, we have two options. One is you like with CMX or Code 5 or something like that. You subscribe and you get a personalized unlimited usage for 1 year. And the second version is bigger companies like that. That you buy a certain amount of requests of this package of a number of requests, and then we don't care who is using that. The whole company in parallel can use that, and these are the two business models. And we cost about half price of CMX.
Okay, yeah, that's very flexible. Do we have any questions in the audience? Yeah, Antonio, please go ahead.
Sorry, I was curious about the information about the pricing. Do you use public available information, or do you have agreement with manufacturing companies so you know the pricing of the different configurations that a user can upload?
Okay. Well, we have three things. First of all, this PanDao is a program based on pure physics. We have more than 35 years experience in optimizing fabrication chains in industry and in academia. And all this knowledge is there inside. Second thing is, of course, this huge data cloud and companies and institutions who run tests for us every third month. We upgrade all this, and the cost is calculated based on the result, including the tooling cost, the time on the machines, and it's distinguishing between an engineer, technician, and a lady who learned just running the machines. And we give three wage levels, like high wage level, medium wage level, and low wage level. And this has been tested around the world in Japan, US, the Netherlands, Germany, and other countries for more than 2 years until we launched the original PanDao product. As for this, for the new product, we are receiving NDA protected the performance and commercial data as well from the company itself. So this is then the real data, and only visible, of course, protected with firewall and everything for the companies who are using that.
Okay, thank you.
Okay. Yeah, that's very clear, Oliver. Is there any other question? Because if not, so we've heard about the PanDao, and then our next speaker for today will be Charles Dumas, the International Sales Director at the Gentec-EO, and he will talk about Miro Altitude, Gentec's new top-of-the-line power meter for laser beam measurement. Charles, please.
So, hello, thank you for organizing this event. My name is Charles Dumas, and I'm here to present you the new flagship display that has just been released, the Miro Altitude.
Well, 1 second, Charles. We don't see your presentation. Just make sure you share it.
You can see it right now? Let me try it again. Thank you. Okay, should be now, okay?
Yeah, that's good.
So, okay. Just rework that. Okay, so the new flagship project that is Miro, and sorry, I just have some trouble with my presentation right now.
No worries, Charles. You can just start all over again when you're ready.
So, just show back my screen. Sorry, guys. I'm struggling a little bit with the screen. And
yeah, that's okay. No worries.
It's okay.
Yeah,
I know it's
all.
all. I have
one. So right now you're not sharing anything, but
yeah, I know.
I'll give you a minute. I'll give you a minute to fix it.
Thank you. It's gonna take 1 second. Screen and okay. Thank you. It's working now, right?
Yeah, go ahead.
Okay. Okay. I just want to cover what is the Miro and the application first. So the application, basically what it is that you want to measure the output power of your laser. It could be from low power to mid power to higher power. And the Miro altitude, it is the display that will work from the low power to the high power. And it's basically the choice, the main choice that you can have for this. The same thing will apply for energy measurement from the low energy, LIDAR application, telecom, spectroscopy, to the medical application, material processing that we saw, or high energy, nuclear fusion, physics, IPL, everything. So this display will work with all the detector head that measure the output of your laser. And why do you want to do this? It's basically to monitor the laser or power energy. Will save you cost. It will give you the compliance on your process, give you a production feedback loop, and it's going to give you the possibility to do burn-in tests monitored 24/7. All of this will give you the compliance on the measurement standard. And what we want to give you is the easiest to use interface to give you the most hassle-free experience possible. Because what you want to know is the output of your laser system, and you don't want to get any kind of trouble in between the test measurement and the accurate measurement. So here it is, the new Miro altitude. What it's going to give you is a 3 display mode, scope chart, needle chart, bar chart, direct access to all the parameters, and possibility to get full statistics and reports. And inside it got a powerful software that is running a modern quad-core processor, lots of space and memory to save the data. And the trend right now is to go with a bigger screen. So in the car, you see the screen is going bigger. Your phone, for the high-end phone, it's bigger. Same logic is behind that with the Miro altitude. And everything is encased with a very strong aluminum machine body. And you can feel it when you hold it. And it's the kind of items that if you do some kind of drop test with it, it will break the floor, not the device itself. It's slim. And it got a very high resolution screen, multi-touch, and it's also anti-glare, anti-fingerprint type of glass, which makes it ready to use in a lab with a safety goggle on. It is able to read all the detectors from Gentec-EO that got a smart connector DB15. You can read all the family of our power meter, photodiodes, low power detector, energy meters, same thing. There's basically all the detectors that can connect to the Miro. And after that you connect it, then you can transfer the data from the Miro to your computer. If you want to work with it for to data transfer through USB-C, there is also the thumb drive that is available to do the connection, to connect it and save it on a USB thumb drive for long-term measurement. And also, we didn't spare any expenses on the battery size. We put a big one that gives you the possibility to run the test for 6 hours at full brightness. It is also coming with a different possibility to way that you can recharge it. There is compatible with USB-C or a barrel jack, and of course we provide this power supply with it, but you don't have to always work with the USB, the one that comes with it. You can share it with different colleagues, and they can use their own power supply to recharge it if it is required. Different output are available, so real size BNC, analog output, different one if you want to work with different one. RS232 with a real DB9 connector, gigabit Ethernet that is available, and programmable I/O that will be available for logic system programmable alarms if you want to automate your system. It got wireless capability. It's under the hood. It's not available for this time at the moment, but it will come at some point when things gonna be ready. But what we wanted to show here is basically it's got the most intuitive user interface. You don't want to read the user manual, and nobody want to open that kind of document, but because you're not going to need it, everything is there up front. Navigation bar, you can see and take some screenshots. You can do some acquisition from the top in the navigation bar. On the measurements setting panels at the left, you will see all the parameters that you will be able to select. You don't need to go into a deeper menu to change any of those parameters. And same thing on the right, you will see a scope that is very quick, and you can adjust after that with your touch screen. Other measurement modes are available, such as a needle that you can do for the optical alignment, and they're very quick, much faster than the physical one, since they don't have to scale up or change on the when they jump from different range. And on the playback, it means that you can reopen a file that has been acquired earlier, and it will replay the same file, and you will see some statistics that are available from the center of the screen, from the minimum energy or power, the average power, what you did measure, and you can rename the file. So basically, there are a lot of things that you can do for the reporting side, for service, for burn-in tests, things like that. And one of the things to keep in mind is the product is only for the beginning. There's new features that are coming, so there's no license or seat or annual subscription. What you buy is the hardware, and we provide all the new feature for free. So there's no surprise cost. Support is free and will always be free. So this is a very interesting product because you will get much more than what you basically got at the beginning, and it will increase the offering new features in the future. So that's the new product that we have, the Miro Altitude. So thank you. And if you have any questions, I'm here.
That's a beautiful product, Charles. Thank you for this presentation. I think you mentioned already, but I'm wondering once again, what is the minimum and the maximum power that you can measure with this device? Meaning, does it fit for both scientific use and in industrial?
It is from picowatt level to 100 kilowatt. And we cover the whole range in between. Depending on the application that you have, there's a parameter that you can connect with the Miro.
All right. So very broadband. Do we have any more questions in the audience? If not, okay, Thomas, yeah, please, from Instrument Systems.
Yeah, Thomas, I have a question. Is there an interface for customers to have a software update? Because it looks quite like a tablet, what I've seen. So is there any interface for customers to have an easy way to update the software?
No. Basically, from the Gentec-EO website, there's a possibility that you will be able to update, get a new firmware update, and from this, there's going to be new features that will be unlocked, and all of this will be coming up for free.
Okay, thanks.
Yes, and Antonio, please go ahead.
Yeah, I was curious because you mentioned that you can measure up to 100 kilowatts. So does it work also with the water-cooled detectors, where you measure the difference in water temperature?
Exactly. So basically, it's a water-cooled detector that you can measure the. Of course, it's big size. It's not something of a pocket-sized detector, but it is a water-cooled detector that you can measure fiber laser up to that level. Of course, there's this apply for the same logic will apply for a smaller detector, but you might not need to be water-cooled at this point.
Okay, and Andreas from CSEM, please go ahead.
Thank you for the presentation, Charles. Could you just elaborate on the hardware, the actual sensor? and then the readout module. Are they necessarily bound together, or could there be the update of one or the other and you keep one or the other?
Basically, if I understood well your question, and correct me if I'm wrong, we already have detectors that are available from years at Gentec, and you can connect them with a new Miro. Same thing. If you have an older display and you you still can connect them with the same, and they are basically interconnected. There's no basically what you already bought is available, will work fine, and for the new product, there's still going to be able to retrofit with the older display.
Okay, so also if you have new detectors coming out, you can still use the readout unit on those. You will keep those forward compatible also.
Exactly.
How about non-Miro detectors? Does it have to be a Miro detector?
It doesn't have to be Miro detector. So all the power, let's say power meter or energy meter that we have, can be connected to a different display or interface as long as they were able to work. But that's basically what we added is a new different type of user interface for what was available, what we had available.
Yeah, perfect. Thanks a lot.
All right. Thank you for your question, Andreas, and Charles, for your presentation. It was great to learn about your new product. And let me pass the word to our last speaker for the session today. So Hooman Banaei, the CEO of Everix, will present the ultra-thin dielectric filters manufactured like optical fibers. And Hooman, please, whenever you're ready. It seems that you started screen sharing, but we don't see it yet.
Can you hear me now?
Yes, we hear you.
All right, great. Yeah. Can you see the screen again?
Yeah, now it's good. The floor is yours.
All right, great. Apologies for that. All right, so yeah, it's good afternoon to everyone in Europe. I would assume that most of you are calling in from Europe. I'm calling from Florida, in the United States, in Orlando. And I would like to thank Epic and our partners at Laser Components for providing this opportunity to talk to you all today. And today we'll be talking about a new class of optical filters that are not manufactured the way traditional optical filters are made. It's more similar to how optical fibers are manufactured. Just a little bit about us as a company. We're a relatively young company. We started in 2015 after a few years of R&D and development. We've now been offering our new form of optical filters for a few years. And we've developed some 34 patents around our core processes, our products, our equipment, and everything that's around this new class of optical filters. And we're now actually in our growth phase. We're getting ISO certified and starting our journey of getting into volume the business, while to this point, we've been primarily for a small and medium-sized business. So, we're very excited that we've recently started a partnership with Laser Components as our OEM partners and development and distribution partners in Europe. So with that, let's talk about the technology. We're all familiar with vacuum coating and how traditional optical filters are made, and this is how the products look like. We're all familiar with that. So what we are adding here to the industry as a complementary solution that adds to the industry is a new way of making optical filters, because there are many segments of the market that require a different level of scalability and economies of scale that allow these high performance optical filters to get into much larger mass markets. And that's where our thermal drawing process comes in, a process that is more similar to how optical fibers have been made. In fibers, you start with a large cylindrical preform form, you draw it down to fibers. In our technology, we start with a multi-layer slab at a really large scale, and then we shrink that entire, we pull the entire stack of layers down to the nanoscale sub-wavelength regime. So, and as a result of that process, we do offer really good scalability, and also the product comes out at least some 20 times thinner than traditional optical filters as a standalone component. And this is helping a lot of our customers to increase signal to noise ratio in their sensors, for example. In many cases, our customers want to miniaturize the device. Let's say if it's a wearable device, you absolutely want everything to be very compact and lightweight. And this is how, you know, a typical filter draw tower, if you will, looks like. And it is nothing like a vacuum chamber. So essentially, we're introducing a vacuum-free optical filter technology. In terms of filter specs, these are the type of specs that we get. As you can see, we can have very narrow and very sharp notch filters up to optical density 6 for notch and multi-notch filters. For long pass and short pass filters, we can go up to OD4. And we've recently launched our bandpass filters, again, up to OD4. And we can operate within the entire visible and shortwave infrared range. The current materials that we're using are acrylic based, so the temperature range is a little bit limited to, you know, applications where you don't have extreme temperature conditions. However, we have higher temperature solutions that are in R&D, and hopefully we'll be introducing them in the years to come. Excuse me. Now, in terms of the technical differentiations of the product itself, there are multiple things that you can consider. One is that because the material can be made flexible, it can be rigid too, but if someone wants it flexible, we can make it flexible. We can make it thin enough so it flexes without cracking. Because of that, we can imagine scenarios where angular shift of a filter can be compensated just by simply curving the filter. And that can save some space in the optical train too, in the optical design. Because the material is ultra thin and it's made completely stress-free, it helps many of our customers to miniaturize their devices. It allows us to cut our filters with a simple CO2 laser to very complex geometries. For example, a donut-shaped filter that goes on the tip of a fiber assembly, or, you know, a very, very tiny sub-millimeter circle that goes on the tip of a, let's say, endoscopic probe. You know, these are the typical things that we can do, but the traditional vacuum coating technology cannot offer that. On the top of that, you can imagine, you know, when the filter is really thin, dispersion is also minimal. So that matters to some applications, not to some others, but we can definitely help our customers reduce the optical path length. Anyhow, so most of the applications that we're currently targeting, and we see more success in the market, they're either in the medical or technology wearable domain. Wearable devices, portable devices, anything that requires lightweight, compactness, and miniaturization, and also in LiDAR industry. Again, both from scalability standpoint and the fact that we can flex these filters and place them on a curved surface to reduce angular sensitivity. And with that, I'll just conclude that, you know, if you have any questions for customers in the European market, you can contact our colleagues at Laser Components, and we'll be jointly supporting your needs. And thank you so much for your attention. I'll be happy to take some questions.
Okay, thank you very much, Hooman. This was a very interesting product. And yes, we have a question from the Technical University of Denmark. Lars, please.
Yeah, hello. Thank you, Hooman, for a very interesting presentation. I have a little question to you. What you present here looks to me very, very close to what 3M Photonics did some 20 years ago. Any comments on that?
Absolutely, yeah. 3M has been using since about 3 years, 20 years ago. They've been using a process called co-extrusion.
Yes.
And that's how they make multi-layer films. However, the co-extrusion process actually has some inherent limitations on how consistent of nanolayers they can make. Because the extrusion process has to take place at a high temperature, and there's a lot of, mechanical contact between, the flow of polymer and internal walls of layer multipliers, extrusion dies, and everything. It is proven that there is a lot of layer thickness distortion that's introduced in the process. As a result, they cannot provide ultra narrow bandpass filter. They cannot provide ultra narrow notch filter with OD6 because they can't populate enough number of layers with consistent thicknesses and enough precision.
And that's why you use acrylate, because I know the other process that 3M developed was based on polyester, which also accounts for the higher temperature processing compared to your process.
Yeah, frankly, so we can use any thermoplastics, the polystyrenes, acrylics, polycarbonates, PI, PS, any thermoplastic is compatible with our process. And we've actually tested the process with polystyrene class 2. Yeah, so what they're really good at is at broadband reflection when you don't necessarily need very high optical density, or you don't necessarily need very sharp edges. We can design, multi-band pass filters with 5 pass bands in the spectrum, right? We can design, multi-notch filters with multiple notches. Those are the kind of things that differentiates us.
Great.
Thank you. Thanks for the question.
All right. Is there any other question? Yes, Ritika from Stensborg, please.
Yes, hi. Thanks for a wonderful presentation. It's a really new way of thinking it. I have never heard about it. So I had just some curious questions. Whenever you are thermally processing something, how do you control, the structure of your material? So whether it's polycrystalline, semi-crystalline, I mean, there's some kind of structural change, and it might be very valuable for, optics and those kind of applications. So do you have any comment on that?
Yeah, I mean, what we currently do is that we intentionally try to only use completely amorphous materials, right? So that at the end, and we also run our process with parameters that do not induce a lot of tension in the material, so that at the end we have a completely polarization-free material. There's no crystallization, but if you switch to a material that has the potential to crystallize, you can imagine that during this process you can induce some crystallization, you can induce some polarization effects without introducing absorption.
Yeah. Okay. Yeah. Okay. Thanks.
Thank you.
Yeah, that's those are very great, interesting filters that you produce. Any other questions? If not, yes, I would like to thank all the speakers we had for today. Let me quickly share a few slides with you. Also let me ask you to fill in the poll that you have right now on your screen as a little feedback for the event we had today. So I will remind you that we had the presentations from Excelitas, Stensborg, PanDao, Gentec, and Everix today. We thank them a lot for the opportunity to learn more about their products. I would like to remind you that at Epic we support you on technology side as well as with the market reports. We provide networking opportunities, access to the new markets and mentorships, as well as HR support and investment. And I'd like to thank my team here for supporting me in this event. One more thing is the upcoming schedule for the events that you are always welcome to participate in. So end of this week on the 21st of October, we have Day of Photonics. I invite you to check out the website of Day of Photonics. There are many events organized by various members of EPIC and also just by organizations worldwide. We continue our session of online events with the OTM on satellite quantum communication on October 24. And on October 28, you're very welcome to join our event that explains how EPIC organizes the delegation trips to countries outside of Europe, where we bring representatives of European companies to explore those new markets for them. So October 28, you will hear more information about this. And we have upcoming delegations in November to Singapore and in December to Israel. We also have a few upcoming offline events, and the closest one will be on November 14 and 15. It will be co-located with the big electronica show in Munich, and the event will be dedicated to electronics and photonics, bridging the two industries, the two sides of one coin. It will take place in Munich again. So you can also see on the screen the rest of the upcoming events. Always keep them in mind. You can find this information at the EPIC website. And with that, I'd like to thank you and close the event for today.